All right, hello everyone. Today we're going to go over your notes on the law of conservation of energy. Now, this is one of the big pillars within physics. It's one of our major laws where it is talking about how energy is conserved, meaning that the total amount will stay the same, but it can change from what version it happens to be in. Because energy can exist in a variety of different forms, and energy can be used from one thing to another. Like when I plug in a fan into an outlet, it can go from electrical energy and convert over into kinetic energy as the object is spinning around in a circle. Or maybe it's where I'm taking gasoline and it's undergoing a chemical reaction where it's releasing that energy so I can use it to power my car and make it go forward. Um, but our law of conservation states that energy cannot be created or destroyed. It can only change from one form into another, and all energy is accounted for. The total the total energy will remain constant, meaning it stays the same in a closed system that is free of outside forces acting on it. So when if there's like an automobile crash, there's no friction, there's no energy being lost to sound. It's everything gets converted from one form to another. Now, in the real world, we end up having some energy loss, mainly due to heat and friction. But in our sense, when we're talking physics, in the most ideal case, we will say that hey, whenever energy goes from one form to another, the total amount will convert, and that means that the total energy we have at the beginning is going to equal the total energy that we have at the end. And our total energy can be any combination of kinetic, potential, or even work, because that's how we'll go about changing our energy. And if we're trying to figure out what the total is, we take our kinetic and we add the GPE together. And I always like pulling up this little demonstrator from PhET. This is the energy of a skate park of a skateboarder going back and forth, say, on a half pipe. So as he goes up or as he gets lower, the potential gets lower. And as he gets higher, the potential gets higher. But if we take a look at the kinetic energy, notice that it's opposite. As it goes higher, it gets lower. And as the object gets lower on the diagram, the kinetic energy goes up. Now, as one goes up, the other one happens to go down. But if you notice over here at the total remains the same the whole time. And if I had numbers on these, anytime I add the kinetic to the potential together, that's going to give me this total amount over here. Total energy can stay constant, but these will go back and forth between one and another. The higher I go, the greater the potential. The lower I go, the greater the kinetic. Now, as we take a look here at the next slide, we'll switch over to the where I can write, because we're going to talk about a couple things. Now, as we take a look here at this diagram, as we happen to take a look at this diagram. So all I want to do here at the very beginning is talk about what type of energy of the roller coaster there is at each point. We always will say, assume the roller coaster starts from rest at the top of hill 1. So if it's starting from rest up here at the top of hill 1, I'm only just some distance above the ground. So I have GPE only at this location. Halfway down, I have a height. I'm going to have GPE. But I'm also going to be moving as I'm halfway down. So I'm also going to have kinetic energy as well. I actually have both forms. Down at the bottom, down here at the bottom of this hill, I don't have a height. I have kinetic energy only because the roller coaster is going to be moving. I come up here to the top of this hill. I'm still going to be moving. I have kinetic energy. I have a height this time, so I have both forms at this spot. At 0.5, no height, so it's only kinetic energy. At location 6, I have a height, so I have GPE, and I'm also going to have kinetic energy because I'm still moving at this location. Location 7, no height, so I have only kinetic energy. Now, I have kinetic energy anytime I'm below this dotted line that I'm drawing, because I would have enough energy to go up to the top of that hill, but I wouldn't have any energy to go any further unless there's an extra chain or something else to pull me the rest of the way up. Now, how we go about trying to figure out our energies. This is done by math. And as we take a look, they're giving us a mass. It wants us to calculate the gravitational potential, the kinetic energy, and the total energy at each different location. Now, how do I figure out amounts of energy? To calculate GPE, that's where I take the mass, multiply by the acceleration of gravity, multiply by the height. To calculate kinetic energy, that's 0.5 mv squared. And to find my total is equal to the kinetic plus the potential. So as I take a look here at location number 1, like I said, whenever we assume that the coaster starts from rest. If a coaster is starting from rest, that means that my KE, when I multiply anything by 0, 2200 times 0 squared, when I multiply by 0, I just get 0. But as I'm looking at the gravitational potential, remember that's mgh. So I'm going to take the mass, 2200. G, I'm using 10 every single time. And then the height, that's given to me on the diagram. The height is 85 meters. And when I multiply those three values together for my GPE, that gives me 1,870,000 joules of energy. And this value is something that is very important for the remainder of the problem. So I have 1,870,000 joules. To find my total amount of energy, I want to take the GPE and I'm going to add it to the kinetic energy. And that's going to give me 1,870,000 joules as my total amount. Now, probably the most important part is the fact that we take a look here on this line. Total energy is constant in a closed system. So that means that if my total energy of the coaster at point 1 is 1,870,000 joules, that means at point number 2, my total energy is 1,870,000 joules of energy. That's my total at location number 2. The GPE at location number 2. We got a mass, 2200. We have G, which is 10, and we have a height of 50. And when I plug this in and do the calculation, so I'm taking 10 times 2200 times 50, and that's going to give me 1.1 million joules of energy. Again, a lot of energy with this, but there is with roller coasters. These are objects that go really fast, they go really high. To figure out the kinetic energy, remember, the total energy remains constant. So if I know this value, and I just figured this out, how I figure out how much is left, I'm going to take the total energy and I'm going to subtract the GPE, and that's going to give me what my value is for how much is left for kinetic. So 1,870,000 I'm going to subtract 1,100,000, and that's giving me 770,000 joules of energy. Looking at location 3, I have a height of 0. Well, the very first energy that I can fill in is my total energy, because total energy remains the same. So it's 1,870,000 joules. Love whenever my computer starts randomly clicking. If I have a height of 0, my GPE is 0. And what plus 0 equals 1,870,000? Well, that's 1,870,000 joules. The total energy remains the same, and the kinetic plus the potential together has to add up to my total. When this is 0, that means all my energy is in the form of kinetic at the lowest point of the coaster. Let's go ahead and take a look here at location 4. Location 4, what's the total energy of the coaster? 1,870,000 joules. Again, total energy remains the same. But location 4, they're giving me a velocity of 36. If I know velocity, find the kinetic energy, which KE equals 0.5 multiplied by the mass, 2,200, times 36 squared. Now again, I'm going to try to do this on my Google calculator, because that's maybe what you guys are probably using out there as you're going through and doing these. But I'm going to take 0.5 multiply by 2,200 times 36 next to the y squared equals 1,425,600 joules of energy. So kinetic energy, 1,425 600. How do I figure out how much is left for the GPE? Well, just like before, I know the total energy. I just found the kinetic. I'm going to subtract from my total to figure out how much is left. So as I take 1,870,000, I subtract 1,425,600 equals 444,400 joules of energy. As I look at location 5, total energy, 1,870,000 joules. Total energy remains constant, doesn't change. Just move 6 up here. As I look at 5, height is 0. My height is 0, my GPE is 0. So how much energy is in the form of kinetic? Well, it has to be the whole thing. In order for something plus 0 to equal the total, it has to equal that. As I look at location 6, what's the total energy? It's the same as all the other energies at every other point of the coaster. Location 6, they're giving me a height of 35. If I know the height, I want to calculate the GPE, which is 2,200 times 10 times 35. When I multiply those values together, times 10 times 35, that's giving me 770,000 joules. Still don't know why that always does that. How do I figure out how much is left for kinetic? You subtract from your total. So when I take the 1,870,000, I subtract 770,000. That's going to give me 1.1 million joules. Let's see here. All right, and continuing on, we got two more little spots. Next, if we take a look here at location 7, well, first energy I can figure out. What's my total energy? 1,870,000 joules. Total energy remains the same. But here at location 7, they're giving me a velocity, 41 meters per second. So the KE is 0.5 multiplied by the mass, 2,200, times 41 squared. When I put that in the calculator, 0.5 times 2200 times 41, and I want to press the square button, equals 1,849,000 1849 Okay. How do I figure out how much is left for my kinetic or my GPE? We subtract from our total, 1,870,000, and then we are going to subtract 1,849,100, and that's going to give me 20,900 joules. Okay. All right, one last example, and that'll wrap it up for these sets of notes. So wants to know a 1.5 kilogram ball is dropped from rest. The fact that it's from rest, that means that the velocity is 0. We got a height of 8 meters above the ground. When we're starting out, okay, calculating the GPE, remember that equals mgh. The mass, 1.5 kilograms. G, we want to use 10 every single time, and multiplied by a height of 8. And when I go through and do this calculation, that gives me an initial GPE of 120 joules. To calculate the kinetic energy. To calculate the kinetic energy, 0.5 mv squared. So we got 0.5 multiplied by our mass, 1.5. But if it's beginning at rest, that means that my velocity initially is 0. And anytime that I multiply anything by 0, I just end up with 0. So to find my total energy is GPE plus KE. And when I take 120 and add 0, I am left with 120 joules. All right, so that's my total energy that ball happens to have. And that will have the same energy the entire time whenever it's falling. So to figure out my energies at location 2, how much energy does the ball have? Well, the ball had 120 joules initially. It still has 120 joules at this point. Well, at point B, they're telling me I have a height of 4. If I have the height, I want to calculate what is the gravitational potential energy. The mass I'm going to take is 1.5. G, always 10 for us doing our calculations. And then we get a height of 4. I type in those three values, 1.5 times 10 times 4. And when I do that, I end up with 60 joules. To figure out how much kinetic energy I have, I'm going to take the total energy. I'm going to subtract the GPE to figure out how much I have. 120 minus 60 is 60 joules of energy. Location C. Location C, the ball reaches the ground at point C. What is the gravitational potential, the kinetic, and the total energy? The total energy is still the same. Because remember, we're going to talk about the energy right before it actually hits the ground. If it has a height of 0, means that I have 0 joules of GPE. So how much must be in the form of kinetic energy at this point? Well, that means that all the energy down at the bottom is in the form of kinetic. All right? And that'll conclude this section of notes.